It is switching at 50 kHz. In one side it will indicate some voltage drop. In second side on the DC rail it must be open circuit. That means its channel is blocking the current. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last video I shared how to trace, how to follow this circuit and how to draw circuit diagram. If you have not watched that video, you can watch the video number displayed on the screen. In this session we will perform cold testing. We will test it live. In this session I will share all possible tips and tricks to take approach to test any switching based power supply circuit, SMPS or PFM based circuit. This MD1801 IC, it is not PWM controller, it is PFM based controller. In PWM controller the switching frequency remains same, the duty cycle or pulse width of that switching cycle is controlled, increased or decreased. But in PFM based switching IC, duty cycle remains same but the switching frequency will change. So this is the technique used to control the voltage in the output side. When there is light load, it will drop its frequency for minimum switching. When load is increasing, it will increase its switching frequency. It is not using TL431. It is using feedback network in primary side from the auxiliary winding. It will switch. It will store energy in this winding, in the core. Then in the off time, that energy will be transferred here and here. When there is no load, a regular voltage that are being transferred in this winding, similar value will be here. But when there is load, same voltage will be transferred here. There is a load current. That load current will also create magnetic field in this winding that will change the voltage level here, because here is regular load and here is load size increased. This increased load size will cause load current. That load current is now making changes in this feedback. Immediately it will control its frequency to replenish more voltage in the output side. RCD snubber will demagnetize the core for making it ready for the next cycle. Let's check it now. If you don't have good experience in electronics, never try to repair, never test it, never open it, because these capacitors are exposed to high voltage. When power is applied, unisolated live voltage will there. We need extreme care for safety. Before touching to this circuit, we will verify voltage on these capacitors. If there are voltage, we will discharge it. These two capacitors in the bridge rectifier output. It is removed from power, but still there are 3.3 volts. If there are high voltage, more than 20-30 volt, we will discharge it properly. For cold testing, we will use multimeter in diode mode or resistance mode or continuity mode based on our requirement. Here is fuse resistor. If we want to test it, we can use resistance or we can use continuity. That is this resistor. Between these 2 points, AC input terminal and bridge rectifier, 10 ohm resistor. Second side is reaching here. Until here the circuit is clear. If we apply power, we will receive 220 volt AC here. 220 volt input, we will measure it, multiply with 1.414 to convert into peak voltage. That voltage value must be present at these capacitors. Suppose I have 220 volt, multiply with 1.414, 311 volt must be present at these capacitors. If we have 311 volt, that's great. That means this capacitor is in good health. If same 220 volt AC here, 220 volt DC here, that time this capacitor is open circuit from inside. It is not maintaining the peak voltage, it is just only taking RMS rectified voltage. That time we need to replace these capacitors. We calculated 311 volt. If this IC is switching, in that condition slightly elevated voltage will there. We calculated 311 volt. If IC is switching, due to reverse EMF, maybe 310, maybe 320, 330 volt, 340 volt will there. Ideally 311 volt in case of 220 volt, but slightly elevation will indicate that this IC is switching, the circuit is working nicely. If there is fluctuation on these capacitors, it is fluctuating randomly, 308 volt, 330 volt, like that. That will indicate that this IC is in reboot mode. It is trying to use maximum current to transfer voltage in output side. But there is something wrong. Maybe in the output side, maybe in the feedback network, that this IC is unable to control its switching. So there are some symptoms. Let's check it now. Before connecting multimeter in resistance mode, in diode mode, verify voltage on these capacitors. If these are 4, 5, 6 volt, you can jumper by using tweezer. If these are high voltage, then you must discharge using any discharging kit. Now it's safe. We will use diode mode. This is positive terminal of this bridge rectifier. We will connect multimeter here and here between both terminals. It is showing 1.1 volt. Reverse the leads. Open circuit. That's good indication. If it is showing same resistance, low voltage drop in both directions, that will indicate that its power line have something wrong. Maybe this IC is bad, maybe any component is damaged, maybe capacitor is short circuit. But now in one side it will indicate some voltage drop. In second side on the DC rail it must be open circuit. That means its channel is blocking the current. Black lead at positive terminal, red lead at one input terminal, one diode, second input terminal, one diode. 609, 617. This 617 due to this 10 ohm resistor. Here approximately same reading. With this resistor, that means this complete path is clear. Move this black lead at negative terminal. AC input terminal, open circuit. Open circuit. It is good indication. Swap the leads. Red lead at positive terminal, one input terminal open circuit, second input terminal open circuit. Move red lead to negative terminal. One diode, second diode. The same one side reading must be slightly high due to this resistor. If there is NTC, the same indication will there. Now from this point, bridge rectifier, this point to the transformer winding one end, to the pin number 5, 6 drive pin of this IC. If we are using external MOSFET, that time the drain pin of that MOSFET. We tested from this point to this point. That means the positive voltage, this winding, all path is clear. When we connected at negative terminal, at this point, if this IC is short circuit, that time it will complete path from this side. So we will receive continuity in both directions here. But now if I am testing here, that means this channel is open circuit. Otherwise this will complete path from here. So that will indicate that this IC is damaged. From drain pin to negative terminal, one diode, and in this condition open circuit. This resistor 1R5, it is showing 0 voltage drop because it is low value resistor. We can test it in resistance mode as well. This is auxiliary winding negative side. We will check continuity here. It is good. Now auxiliary winding this end to this point, open circuit, one diode. This time I tested this winding with this rectifier. If this rectifier is short circuit, it will give indication in both directions. Now we will check voltage drop at VCC pin. Sometimes this VCC capacitor is short circuit. One side, this one diode, that is this diode. If I am testing here across this capacitor, I am also testing this diode, because when I will connect here, this diode is being tested from this path. So it is good indication. If this IC is short circuit from VCC pin, it will give indication. There will be three indications here now. One, this diode is damaged, capacitor short circuit, or maybe IC internally short circuited. If we have short circuit at VCC pin, when we apply power, these resistors will charge this capacitor. That time the IC will off. When it will obtain approximately 6 volt, this MD1801 IC will start switching. Before 6 volt, it will remain off. When voltage will present, that time it will start switching. It will allow current from this negative terminal to here and in the transformer winding. So current will flow here. Now we tested VCC section, and now we will verify snubber circuit. Pin number 5 and 6, drain pin, and this diode. That is this diode. If this diode is short circuit, that time the IC will switch, but the output voltage will not regulated in the output. That voltage will approximately half or less than half value. If 5 volt power supply, maybe 2 volt, 3 volt will there in the outputs. R, C and D. These components will not demagnetize the core. Here is feedback network. These resistors in the output side. This rectifier. Sometimes it is short circuit. When it is short circuit, it will cause to blast this capacitor. Because there is parallel resistance here, that is dummy load resistor, so it will not become open circuit, because that resistor is providing discharging path. We test capacitor here. In one side it is showing this rectifier value, but in opposite direction capacitor will charge until a specific limit, then it will remain stable at that value. Why? Due to this resistor. So this is the cold testing. Now we will apply power. When power is applied, always take care for safety. We will not touch any component. I will apply power using series lamp. AC voltage 234 volts. 330 volt must be present at smoothing capacitor. It is showing 339 volt. This 10 volt elevation is indicating that this IC is switching. If it is not switching, maybe 330 volt, or 325 volt will there on the capacitor. Second step, we will check voltage on this capacitor. If IC is good, it is working normally, VCC capacitor will stable. DC voltage, here is VCC capacitor 5.8 volt. If here is fluctuation, that will indicate that IC is not taking feedback, it is not maintaining the output voltage, so it is trying to use maximum force to provide regulated voltage in the output. If IC is not starting, maybe we are not receiving voltage on this line. What is the indication? Capacitor is damaged, diode is damaged, or IC is damaged, or its startup circuit is bad. This time in the output we have 4.94 volt. When we are testing in secondary side, we can check blocking voltage across this rectifier. That is the same. If we test here at output terminal or across this diode, rectifier diode, Schottky rectifier, that will be the same. Now I will connect oscilloscope. To connect oscilloscope, we need to consider something. The first, isolation. You can use isolation transformer to power up oscilloscope and to power up DUT, device under test. If you are using unisolated or you don't have isolation transformer, that time we will not use safety ground for the device and the oscilloscope. We will use 2-wire cable to power up oscilloscope. Then we will not touch any component. We will not touch any metallic part of the oscilloscope, because when we are using 2-wire cable, if we are using unisolated power supply line voltage, we are using 2-wire cable and we connect oscilloscope even low side at ground, but that is unisolated ground, hot side ground, that may expose in these metallic parts, so we will never touch these terminals. When we want to connect any signal, we want to poke it, we will take special care that we will remove power and then we will connect oscilloscope. Before touching the circuit, verify DC voltage on these capacitors. If here are high voltage, discharge it, but it is 8 volts, it is safe. This is smoothing capacitor, negative side. We will take negative side of this capacitor as a hot side ground as a reference point for our oscilloscope. Now if we want to use oscilloscope, the best way to test signal at this pin number 4. This is low value signal, that is switching pulse as a current sense circuit. Another point, we will turn on oscilloscope. We will set oscilloscope test probe to 10x. This is 1x attenuation, 10x attenuation. We will count the number of grids in the vertical direction. 1, 2, 3, 4, 5, 6, 7, 8. What is the maximum voltage here? 10 volt per grid. 8 by 10. 80 by 10. 800. 8 grids. 1, 2, 3, 4, 5, 6, 7, 8. 8 grids. 10 volt setting from here. 10 multiplied by 8. 80 volt, 10 time attenuation. 80 multiply with 10, that is 800 volt. So this is the capability of this oscilloscope. If I want to test 220 volt line voltage, 220 multiply with 1.414, that is peak voltage 311 volt, multiply with 2, 622 volt peak to peak voltage will present in line voltage. So if you want to test line voltage directly from here, that will 622 volt in case that voltage are 240 volt, 678 volt. So that is also within limit. We can test line voltage here. If I have 240 volt, multiply with 1.414. If you are discussing DC voltage on DC rail 339 volt, this 339, if this RCD snubber is not working properly, that time 339 multiply with 2, 678 voltage stress may be present here. So if you will use this oscilloscope probe to connect between these 2 points, because it has its own capacitance, that time if the IC is good, it is switching, maybe we will damage this IC because we are connecting a parallel load, because 678 volt, 670 volt stress will be exposed to this probe. So best way when we are testing any power supply SMPS to test signal from current sense resistor, either built-in MOSFET or external MOSFET. If you are using external MOSFET, that time at source pin there is a current sense resistor. It will be a safe decision to test signal at this point. Now I connected pin number 4, that is current sense pin, ground at ground, high side signal at this point. It is switching at 1.7 kilohertz only because there is no load. Now I will connect load. It is switching at 50 kilohertz. It is drawing 1.13 ampere. When load is connected, switching at 55 kilohertz, 58 kilohertz, it is current sense pulse, that voltage are being dropped across this resistor. If I will disconnect this load, single pulse with the same duration is there. Because this time the load is not taking too much current. The load is just only this USB tester. If you will remove this, it will switch in few hertz or few hundred hertz, maybe 500 hertz, 600 hertz, like that. I removed USB tester. Just only capacitor is present. Sometime it is sending pulse at 100 Hz, 71 Hz as per requirement. So it is power saving technique. When I connected this load, it started to consume little amount of current to power up its display. But when we will connect load, (57 kilohertz). We can also test at the drain pin. Now I will connect at pin number 5 and 6. But I will not recommend to test this high amplitude signal. It is 53.19 kilohertz signal. This is turn on time of the switch because we are testing between ground and this pin. So it is turn on time. When turn on time, this pulse is now at low level. This time the switch is on. In the same time we are receiving the current sense signal that pulses with this duration. That after this is off time. When it is off, it is transferring energy in the second side, and these are oscillation pulses that RCD snubber and capacitor will make tank circuit with this primary winding. I hope you enjoyed this process. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.